5475. Given, true course is 105 degrees, true heading is 0, 85 degree true airspeed is 95 kts, ground speed is 87 kts. Determine the wind direction and speed. A. 0 20 inch and 32 knots. B. 0 30 inch and 38 knots. C. 200 foot and 32 knots. The correct answer is A. Using a computer model E6. B. 1. Adjust the azimuth of the compass such that the real index is at 105 degrees. 2. Slide board with a speed of 87 knots so the grommet is on the ground. 3. By comparing the route and direction, find the WCA. 105 degrees, 0, 85 degree equals 20 degrees left. 4. Draw a pencil to represent WCA at the TAS arc, 95 knots. 5. Adjust the azimuth of the compass so the pencil mark is on the center line. 6. Write the wind speed and direction as the number of units between the pencil dot and grommet, respectively, 0, 20 degree and 32 knots. 5476. Given, true course is 345 degrees, true heading is 355 degrees, true airspeed is 85 kts, ground speed is 95 kts. Determine the wind direction and speed. A. 0 95 degree and 19 knots. B. 113 degrees and 19 knots. C. 238 degrees and 18 knots. The correct answer is B. Using a computer model E6. B. 1. Adjust compass azimuth such that the correct index is 345. 2. Slide board with a speed of 95 knots so that the grommet is on the ground. 3. Calculate the WCA by evaluating the route and heading. Right. 345 to 355 degrees equals 10 degrees. 4. Use a pencil to mark 85 knots as the WCA at the TAS arc. 5. Adjust the azimuth of the compass so the pencil mark is on the center line. 6. Write 114 degrees and 19 knots under the true index for wind direction and units between the grommet and pencil dot, respectively. 5478. Given, distance off course is 9 miles, distance flown is 95 miles, distance to fly is 125 miles to converge at the destination. The total correction angle would be A. 4 degrees. B. 6 degrees. C. 100 degrees. The correct answer is C. 1. Calculate the number of corrective degrees necessary to parallel the desired course. Number of miles flown to parallel 95 times 9 times 6 is equal to 5.68 degrees. 2. Ascertain how many further degrees of adjustment are needed to change the course. 60 miles off course, correction number of miles left until interception 9.60 times 60 is equal to 4.32 more feet to intercept 125.3. To calculate the total correction angle needed to converge at the destination, add the degrees needed to parallel the path and the degrees needed to intercept the course. 5.68 degrees to parallel plus 4.32 degrees to intercept equals 10 degrees total to converge. 5532. When checking the course sensitivity of a VOR receiver, how many degrees should the OBS be rotated to move the CDI from the center to the last dot on either side? A. 5 degrees to 10 degrees. B. 10 degrees to 12 degrees. C. 180 to 20 degrees. The correct answer is B. The CDI, course deviation indicator, is a needle on a VOR receiver that indicates the aircraft's position relative to the selected VOR radial. The CDI is typically divided into 10 dots, with each dot representing 1 degree of course deviation. To check the course sensitivity of a VOR receiver, tune the receiver to a strong VOR station and center the CDI. Then, rotate the OBS, Omni Bearing Selector, knob 10 to 12 degrees in either direction. The CDI should move to the last dot on either side. If the CDI does not move to the last, the VOR receiver may need to be adjusted. It is important to note that the course sensitivity of AVOR receiver may vary depending on the aircraft's altitude. At higher altitudes, the VOR receiver may be less sensitive, requiring a greater change in the OBS knob to move the CDI to the LASTA. 5533. An aircraft 60 miles from AVOR station has a CDI indication of 1/5 deflection. This represents a course center line deviation of approximately A. 6 miles, B. 2 miles, C. 1 mile. The correct answer is B. 1/5 deflection on a CDI represents 2 degrees of course deviation. At 60 miles from the VOR station, 2 degrees of course deviation represents approximately 2 miles. This is because the CDI is calibrated to represent course deviation in nautical miles per 10 degrees of deflection. So, 1 degree of deflection represents 0.6 miles at 60 miles from the VOR station. Since 1/5 deflection is 2 degrees, this represents 1.2 miles. It is important to note that this is an approximation and the actual course center line deviation may vary depending on the aircraft's altitude and the VOR station signal strength.